Today's video lesson is on perimeters and areas of similar figures. Objective today is to find the perimeters and areas of similar polygons. You can use ratios to compare the perimeters and areas of similar figures. So what we're going to discover today is if I have two polygons that are similar, so I'll draw two rectangles and I'll make them similar. So if it's a rectangle, I know all angles are 90 degrees. And I'm going to make the two rectangles similar. So if this is 3, this is 5, I'll make this 6 and 10. Okay, so I'd have these two polygons, they're similar. That means all corresponding angles are congruent, and the ratios between corresponding sides are also congruent. So if I want to know the perimeter, so let's do the perimeter. Okay, we'll do here's shape A, here's shape B. So the perimeter of A is, add up all your sides. So 5, 5, 3, 3 is 16. So the perimeter of A is 16. If I want the area of shape A, it's 3 times 5, which is 15. So there's my perimeter, there's my area. Now let's go to B. So I want the perimeter of B. So 6, 10, because opposite sides are equal. So I have 10, 10, 6, 6, so that's 20, plus 12, which is 32. And the area of shape B is 60. Now let's look at these two values that we now have and compare them. So let's now compare the perimeter of A over the perimeter of B. Well, the perimeter of A is 16 over 32, which is a half. Let's do the area of A over the area of B, which is 15 over 60, which is 1/4. Let's compare my side ratios. My side ratio is 3 over 6, which is a half. So since these figures are similar, my side ratio is the same as my perimeter ratio. The connection between the perimeter ratio and the area ratio is that the area ratio is equal to the square of the perimeter ratio. And this only happens when the two polygons are similar. So to summarize, perimeters and areas of similar figures. So the ratio of their perimeters is A over B. So if your scale factor, okay, is A over B, so my scale factor is A over B, then my perimeter ratio is also A over B. Therefore, my area ratio will be A squared over B squared. So scale factor, perimeter ratio have the same ratios. The area ratio is the square of the perimeter ratio, or it's the square of the scale factor. So let's try some examples. The trapezoids at the right are similar. The ratio of the lengths of corresponding sides is 6 to 9, which reduces to 2/3. What's the ratio, smaller to large, of the perimeters? Well, since my scale factor is given as 2/3, my perimeter ratio is equal to the scale factor, so that's also 2/3. My area ratio is equal to the perimeter ratio squared, which is 2 squared, 3 squared, which is 4/9, and that's the area ratio. So I answered basically questions A and B all in one. So scale factor was 2/3, therefore scale factor and perimeter ratios are congruent. Let's zoom in. And area ratio is equal to the perimeter ratio squared. Since our perimeter ratio is 2/3, you square them, get 4/9. And that's the area ratio. So again, your scale factor is equal to the perimeter ratio. Your area ratio is equal to the scale factor squared, or it's equal to the perimeter ratio squared. Let's try another example. The area of the smaller regular pentagon is about 27.5 centimeters squared. What is the best approximation for the area of the larger regular pentagon? So here we need to set up a proportion. So right now I have my area of the smaller is 27.5 centimeters squared. The area of the bigger one, I don't know. But what I am giving is my scale factor. My scale factor is equal to 4/10, which is 2/5. Therefore, my perimeter ratio is also 2/5. Therefore, I can also find the ratio between the areas. The area ratio is equal to 2/5 squared, which is 4/25. So when you're dealing with similar areas and perimeters, you should always find your three ratios: your scale factor, your perimeter ratio, and your area ratio. Now, what's missing? Okay, I'm missing my area of the big pentagon. So if I'm missing area, okay, I need my area ratio. Well, my area ratio, as I found over here, 4/25. So 4/25 is my area ratio. Therefore, I can set up a proportion, 4/x. Because the ratio between the areas must reduce down to 4/25. I can now cross multiply and solve. So I have 4x equals 100 divided by 4. So when I have 100 divided by 4, I have 25. Oh, whoops, sorry. Sorry. That's not it. Excuse me. Sorry. This is my area ratio. So the area of the smaller one is 27.5 over x. There we go. Sorry. I caught my mistake. So you set your area ratio equal to your known areas. My known area is 27.5 over unknown x. Now we cross multiply. So it is 4x equals, so we do 27.5 times 25. You get 687.5. 687.5 divided by 4, divide by 4. And you get 171. So x is equal to 171.9 centimeters squared. Okay. So when you use your area ratio, you take your area ratio, set it equal to the ratio using one of the given areas and using x for your unknown area. We'll do another one. Scale factor of two similar parallelograms is 3/4. So again, first step, find all three ratios. So if my scale factor is 3/4, my perimeter ratio is 3/4. Therefore, the area ratio is equal to the square of the perimeter ratio, which is 3/4 squared, which is 9/16. So the area of the larger parallelogram is 96 inches squared. So the area of the bigger one is 96 inches squared. What's the area of the smaller one? I don't know. Okay, I don't know is x. Well, I'm missing area, so I need my area ratio. Here's my area ratio, 9/16. Therefore, the ratio between the big and small must reduce down to 9/16. So x is up top, 96 in the bottom. The reason why x is up top, because I'm comparing the small to big. So I compare small to big. The area of the small compared to the area of the big must reduce down to 9/16. Cross multiply. 16x equals, now we have to do 9 times 96. 864. Divide by 16. And you get x is equal to 54. So the area of the smaller is 54 inches squared. Let's try another one. Scale factor of the dimensions of two pieces of similar window glass is 3/5. So my scale factor is 3/5. Therefore, my perimeter ratio is 3/5. Therefore, the area ratio is 9/25. The smaller piece costs $2.50. How much should the larger piece cost? Well, piece of glass is area. So I have an 9/25 equals 250 over x. Okay, I'm not talking about the perimeter cost of a glass, I'm talking about the cost of the glass itself. The glass itself is talking about area. We're buying the whole glass piece, so it's area. So 250 over x. So let's cross multiply and solve. So you have 9x equals, so we have 2.5 times 25, 6250. And if we divide by 9, we get $9.94. So divide by 9, x is $6.94, the cost for the bigger piece of glass. So now let's use area ratios and work backwards and find perimeter ratios. The triangles at the right are similar. What's the scale factor? What's the ratio of their perimeters? Well, if we find the scale factor, we know the ratio of the perimeters, because remember, scale factor is equal to perimeter ratio. So I have my areas, so I got to work backwards. So if my area ratio is equal to 50/98, therefore my perimeter ratio is going to equal to the square root of the area ratio. So working backwards. So let's take the square root of 50/98. So don't forget, we can reduce first before we take the square root. So 50/98 reduces to 25/49. So this is the square root of 25/49, which is really the square root of 25 over the square root of 49, which is 5/7. So there's my perimeter ratio. My perimeter ratio is 5/7. Therefore, my scale factor is also 5/7. And we're not solving for our missing side here. So there we go. So new formula or new rule you need to remember, that if you're given the area ratio, take the square root of the area ratio and you get your perimeter ratio. So perimeter ratio equals the square root of your area ratio. Your scale factor will also equal the square root of your area ratio. Let's try a different example. Areas of two similar rectangles are 1875 feet squared and 135 feet squared. What's the ratio of the perimeters? Okay, so I have the area of the big one, which is 1875. I have the area of the small one, which is 135. So let's find my area ratio. When I do my area ratios, I always compare the small over the big. So the small area ratio compared to the big area. So 135 over 1875. So this reduces to, remember, always reduce your fractions whenever possible. So 135 over 1875 is 9 over 125, which is 9 over 125. Okay, now that I have my area ratio, I take the square root of it to get my scale factor or perimeter ratio. So my perimeter ratio is going to be the square root of my area ratio. So my perimeter ratio is equal to the square root of 9 over the square root of 125. Square root of 9 is 3. The square root of 125, let's break it down. 125 is 25 and 5. So we have the square root of 25 and the square root of 5, but that's going to be 5 radical 5. So square root of 125 is 5 radical 5. Can't have a radical in the denominator, so we have to rationalize. So I'm going to multiply both sides by radical 5. So I have 3 radical 5 over 25. Because radical 5 times radical 5 is 5. 5 times 5 is 25. So there is my perimeter ratio. And that concludes this lesson. Here are some practice problems you can work at and practice. Again, main concepts for this lesson. Okay, so concepts. Your scale factor equals your perimeter ratio. Area ratio equals your scale factor squared, or area ratio equals your perimeter ratio squared. Your scale factor will equal the square root of your area ratio, or your perimeter ratio will equal the square root of the area ratio. If you have any questions, email me or ask during